Let's look at today's Leetcode problem 440, kth smallest in lexicographical order. Before starting this problem, let us look at a motivational quote for today. Education is the most powerful weapon which you can use to change the world. Nelson Mandela. When you study and gain knowledge, you are preparing to solve problems, build solutions, and make an impact. Every hour you spend learning is a step toward a better you and a better world. It opens up opportunities and a pathway to success. When people are educated, they think for themselves, question injustice, and bring about positive change. So, yeah, while we continue to learn and grow or discover new things, eventually we are uh, having to build solutions that help people around us. So, if everybody is educated, people or the society which we live in becomes a great place as well. So, that's the whole agenda, that's the whole idea of this quote, where education is the tool which helps everybody come together and build a positive society for everyone's upbringing. Okay, so let us understand this problem statement here. So, given two integers n and k, return kth lexicographically smallest integer in the range 1 to n. So, like yesterday's problem, we are required to calculate lexicographical numbers ranging from 1 to n. So let's say here n is 13, we get all these numbers like 1, 10, 12, 11, 12, 13 and 2, 3, 4, 5, 6, 7, 8, 9. So here there are 8 plus 5. So there are 13 words here as you see, 13 numbers as you see. So the smallest number is 10 uh, at the kth index. Kth index as in sense this is 0, 1. So k is equals to 2 minus 1. This is the specific index that we should be looking for. Similarly, this is an example where if n is equals to 1 and k is equals to 1, we need to return the zeroth element which is 1. So that's the whole thing. So let us think about an approach like yesterday we had looked into DFS, but today we are asked to find a specific index from the lexicographically generated array. So we might need to optimize our approach from yesterday or think a bit different. So yeah, so let's say in case we are given with the number like uh, 13 or whatever it is. So firstly we start off with number 1 and we append number 1 and a 0 to next to it, and this goes on like uh, 1 1 2 1 2 1 2 3 and 1 9. And once we let's say we start off with an empty, and this will be branching out here and this will go out here. So similarly, we would be going with 2, 3, so on. And this can again go on with subtrees like 1 plus another 0. So here there are two zeros, and this can go on like 101, 100 and 1, 102, so on, right? So yeah, considering this, we know that there is a kth limit, a kth number, and also an n. So it would be good for us if we consider the kth number that is being asked to at the specific index, and also the limit at which the lexicographical numbers are to be generated, and from which the kth number can be picked. So we generate all these trees, and we skip uh, so we simulate all the numbers and we skip the entire subtree. If, for example, let's say we want to uh, get a number, say, in between k is equals to, let's say, this will range from 10, 11, 12, 13, 14, 10 to 19, which would be 10 numbers, and this would be one number, so it would have 11. Let's say if it is 13, then it would be meaningful for us to figure out something around the first row only, while we can just simply skip this part of the computation in our DFS function. And we can simply go out here where we know that this doesn't generate a subtree because n might be 13 and we are looking for let's say 12th element. Then the 2 will be an output somehow here, right? So in our case, uh, let's say 12th element here was 8, right? So yeah, it would be meaningful for us to look in the this level when we are looking for numbers greater than 12. Okay, so just to repeat, let's say if we are asked to generate a specific range of numbers, let's say in our example 1, 13, and we generate our numbers based on this order 1, 2, and so on. Before coming to this, we also add in 1, 0, and since we see this 1, 3 less than the range of numbers that are required to be generated, so we go on till 1, 1, 1, 2, 1, 3, and uh, the lexicographical order will be 1, 1, here will be 1, 2, 3, 4, 5, and then it will be here. So let's say if we are looking to figure out some numbers greater than 6 or greater than 5, so let's say 5, then it would be meaningful for us to skip this entire piece of execution in our DFS and then look for only the numbers that are in between 1 and, or in the first level, we can say, right? So that's the whole idea. uh, so let us come up with a solution on how we can solve this problem. So if I would have to give it an give it a high level design on how we can have our code written. So we somehow will figure out the number of steps that we need to generate a specific range of numbers with a function where we might be returning the number of steps. The steps, the way that we do it here is, firstly we calculate the steps. Let's say with at the start we might be having n, or the last number, whichever is the minimum, and minus first plus 1. And let's say our first value might take first plus 10, and the last value might take up last into 10, just to keep it plus 9. So that's the whole thing. So once we have the number of steps, we use those number of steps to be calculated at every kth value, which is until we reach a specific index. So we calculate, let's say, while k is greater than 0, we check the steps with the function that we have, and if k is greater than the steps, then we k plus step. So if k is less than steps, then we uh, let's say if k is less than or equal to steps, then we decrement k is equals to k minus steps, and we increase the prefix by 1, just else we go to the next step where we increase prefix into 10 and k minus 1. Yeah, so this is the whole idea, and we can simply return prefix as our output. Okay, so let's see how we can approach this in our Leetcode editor. So initially we are going to build our function which helps us return the number of steps, and we are doing that this way where we so this will be our starting point for the number, and then we will also make sure the index that we are looking for, the kth minus 1, k minus 1 will be the index from the lexicographical in items. So so if we need to understand what's going on here, this is the main piece where we continuously check as until the k is greater than 0, and we return prefix, which would be our final output. But yeah, here we calculate the steps which lie within the range of numbers that we should generate. Let's say 13 would have one order, and that is done here with respect to this function which returns the second order. So uh, we initially assign all these values with prefix, which would be 1, and n will be 13. And if we need to calculate here the number of steps initially is 0, and mat.min which is n 13 comma last. So it will be 13 minus 1 plus 1. So, or it would be 13 plus 1, and the first will be first into 10, which means 10, and the last number will be 19. So this is the first thing, and uh, we check if 10 is less than or equal to n. While it is still true, then we continue, and here if we see steps which wherein we had 19 as our math.min, n was 1, or where was the n? Okay, so n was initially as 13. So 13 minus last was 19, so we stay with 13. 13 minus first, which was 10. 3 plus 1, 4. So 4 is less than n which was 13. So we jump out of this while loop and we just say step is equals to plus 1, or step was 4 steps. 2 steps, right? Where one was checking within the range 1, and next thing was we were incrementing it by plus 1 only, right? Okay, so in this if loop we are mainly checking if k is greater than or equal to steps, which means uh, if it doesn't lie under the prefix, then we skip the entire subtree calculation and we go to the next step where the kth number might lie. So that's the whole idea in the if else statement that we have there. Okay, so let me try submitting the solution and let me see. As you can see, the solution gets submitted. If we need to understand the time and space complexity of the solution, we are not having to store any data here. So it would be O of n with respect to space complexity, and time complexity will be n log n plus n log n, as we might be iterating n log n times at the max, and here we also have another for while loop which runs n log n times. Okay, so if you found this video helpful, please like and subscribe to my channel. Thank you.